Hello everyone, I am Joselito Jaime from Pamplona, Negros Oriental. Today, we're going to talk about the rules for differentiating functions. But before we start, I want you to know the objectives that you're going to accomplish at the end of this lesson. First, you will be able to familiarize the various differentiation formulas. Second, apply the differentiation formulas in finding the derivative of an algebraic function. Third, use the product and quotient rule in finding the derivative of an algebraic function. Are you ready? Let's start. In the following formula, let u, v, and w be differentiable functions of x, and let c and r and n are constants. The first rule that we're going to talk is called the constant rule, given in dx of c is equal to 0. This is read as the derivative of c, or a constant, is equal to 0. This means the derivative of any constant is always equal to 0. So here's an example. Suppose we have a function, say y is equal to negative 2. So in this case, this is a constant function. So to differentiate, we need to differentiate both sides of this equation. So first, we write the symbol for differentiation, which is dx, and then follow with the letter y is equal. Again, as I mentioned earlier, we need to differentiate both sides of the equation. So we need to write negative derivative of negative 2. Now, copy the derivative of y is equal by applying the constant rule. Constant rule here says that the derivative of c is equal to 0. Hence, since this is constant, the answer is 0. The next rule that we're going to talk about is called the power rule. It is denoted in the symbol dx of x to the power of n equals n times x raised to the power of n. By the way, this formula is read as derivative of x to the power of n with respect to x is equal to n times x raised to the power of n minus 1. Right? To illustrate this formula, I will give you a function. Suppose we have y is equals to x to the power of 8. So again, in differentiating in a function, we need to differentiate both sides of the equation. So we have the derivative of y with respect to x, since we are differentiating with respect to x, and then the derivative of x to the 8 with respect to y. So by applying this formula, we can notice that here our n is equal to 8. So by following this formula, we can now have n, which is equal to 8, times x, and then another n, which is equal to 8, minus 1. So simplified, we have 8, and then x, and then we have 7, since it is 8 minus 1. Another example, we have the derivative of x with respect to x. So as you notice, the exponent of x here is 1. So we can write, or we can just follow this formula, which is our n is equals to 1. So we have 1 times x, we have x, and then we have n again, which is 1, and then minus 1. And then after that, simplify, we have 1, and then 1 minus 1, the exponent of x, is 0. So x to the 0 is 1, correct? So this is 1 times 1 which is equal to 1. Any questions so far? If none, let's continue. The next formula is called the constant multiple formula. It is given with the formula dx of c times u is equal to c times the derivative or dx of u. By the way, it is read as the derivative of c times the function u with respect to x is equal to c times the derivative of u. So to illustrate this formula, I will give you some examples. So suppose we have y is equals to 3x squared. So again, since this is a function, we need to differentiate both sides of the equation. So we have the derivative of y is equal to the derivative of 3x squared with respect to x. So far, as you can observe, in this pattern here, we can consider 3 as our constant and u as the x squared. So, we're going to apply this formula now. We have the derivative of 3x squared is just equal to 3 times the derivative of x squared with respect to x. And we will now apply the second formula in this part. So we have 3 times, since n here is 2, we can now have 2 times x raised to the power of 2 minus 1 from this formula. And then, simplifying, we have 6, and then we have x. And then 2 minus 1 is 1. So we'll not write 1 here. So the answer is 6x. We already done with the first 3 formulas. We have now the fourth formula. The fourth formula, by the way, is called the sum rule. So the sum rule states that the derivative of the sum of functions u, v, and other functions is equal to the derivative of u plus the derivative of v plus and so on. So let me give you an example in this formula. Suppose we have a function y is equal to 3x squared plus 4x minus 1. So we can apply this and treating each term of this as function. So again, in applying this formula, we need to differentiate both sides. We have the derivative of y is equal to the derivative of 3x squared plus 4x minus 1. So in this rule, we can notice that the derivative is just simply distributed on each term. So hence, we can also apply that in this trinomial. We have the derivative of 3x squared plus, since this is plus, the derivative of 4x, and then minus, since this is minus, the derivative of 1. So in this expression, we are now going to simplify this by applying the previous formulas that we have. So the first term, the derivative of 3x squared with respect to x, is just simply 3 times 2x to the 2 minus 1 by applying this formula. Plus, we have the derivative, as I gave an example earlier, of 4x is just 4. And then the derivative of the constant is always equal to 0. So, we have now 6x, which is 2 minus 1 is 1 plus 4. So the final answer is 6x plus 4. We are now in the fifth formula, and the fifth formula is the generalization of the second formula. So here we have the derivative of a function u raised to n with respect to x is equal to n times u to the power of n minus 1 times the derivative of u. So in this formula, we have a function y is equal to x minus 1 quantity to the 6th. So as you can notice, it is in the form of u to the n. We can express this as our u, and the 6 here we can express this or equate this with n. So we will now apply this formula. So since n is equal to 6, differentiate or the derivative of y is equal to 6 times u. What is u? Our u here is x minus 1. And then we have n minus 1, so we have 6 minus 1, which is, or and times the derivative of x minus 1, since our u is x minus 1. So simplify. So we have 6, we have x minus 1, 6 minus 1 is 5, times, since this is a binomial, we can apply the fourth formula. We have the derivative of x minus the derivative of 1. Again, we will simplify this expression. We have 6, copy, x minus 1 to the 5th, times, what's the derivative of x? The derivative of x is 1. So, times 1 minus the derivative of 1 is 0. So, therefore, we have now the answer, final answer is 6 times x minus 1 times 5, and the derivative. Alright, we are now in the sixth formula. So the sixth formula is called the product rule. So it is read as the derivative of the product of u and v is equal to u times the derivative of v plus v times the derivative of u. So to illustrate this, I have a function here, which is y is equal to x squared minus or plus 1 times x minus 1. So as you know, this is the product of two functions. So we can treat this is our u, and also we can treat this as our v. And we can pattern, or we can just use this formula to solve for the derivative of this function. So we have the derivative of y, since in the first term we have u, so just copy u here, which is x squared plus 1 times the derivative of v. So the derivative of v, which is x minus 1, plus we have now v. So the v here is x minus 1 times the derivative of u. So the derivative of u, sorry, the derivative of x squared plus 1. So simplify. So just copy x squared plus 1. This is the derivative of x minus 1. So we can just distribute the derivative. The derivative of x is 1 minus the derivative of 1 is 0. So, or simply, it is just 1. Plus, copy x minus 1 times the derivative of x squared plus 1. So we will just distribute the derivative. So what's the derivative of x squared? The derivative is 2x, and then the derivative of 1 is 0. So we have now x squared plus 1 plus this which is simplified to x. X times x is squared minus 2x. So since this is, or these two are similar terms, we have now 3x squared, so it's 2 plus 1, 3, and then copy minus 2x, and then copy plus 1. So the final answer of the derivative of y is equals to 3x squared minus 2x plus 1. We are now on the seventh formula, and this is called the quotient rule. So the quotient rule is given the derivative of u all over v is equal to v times the derivative of u minus u times the derivative of v all over v squared. So to illustrate this, I will give you an example. Suppose we have y is equal to x minus 1 all over x plus 3. So in this function, we can treat the numerator as our u and then the denominator as our v. So if that's the case, we are now going to apply the differentiation formula for this function. So the derivative of y with respect to x is equal, so since this is our u, this is our v, so we will write firstly v. So we have x plus 3. What's next? The derivative of u. So the derivative of u is x minus 1 minus u. So we have x minus 1 times the derivative of v, which is x plus 3. And lastly, the denominator, don't forget, you have squared. So we have v, which is x plus 3 quantity squared. So now we're going to simplify the numerator. We have x plus 3 times the derivative. So what's the derivative of x? The derivative of x is 1. The derivative of negative 1 is 0. So we're going to write 1 minus, copy, x minus 1. And next, the derivative of x, still 1. And the derivative of 3 is 0. All over x plus 3 quantity squared. So, simplifying, we got x plus 3 minus x plus 1 all over x plus 3 quantity squared. So, x minus x is equal to 0. 3 plus 1, we have 4. So, the derivative now is 4 all over x plus 3 quantity squared. And this is now the answer. So, to sum it up, I will send you a set of problems on your email or on your messenger for your quiz. Thank you.